Okay, so the plan for today's lecture is to really follow up on, in some ways, where Ariel left off the last lecture yesterday. Oops, what happened here? Where he talked about computing price indices. There he was talking about using hedonic methods, which are very kind of closely linked to what we're doing here, right? And there's a sense in which you could say, well, the hedonic equation or the pricing equation, right? The equilibrium equation coming out of demand and cost, that's a function of characteristics. So what I'm going to talk about today is actually going back to the demand systems and saying, suppose we're actually interested in very similar type of questions, but we're going to use estimated demand systems to try to do that. So that's basically the goal. Now I should say we've noticed yesterday that we tend to go kind of quicker or faster than we thought. So lectures that we planned for an hour and a half tend to take a little bit longer. This lecture actually, even when I planned it, I kind of knew it was a little bit short. So what I added actually this morning is I actually added a separate set of slides that I might or might not talk about, going back to kind of issues that we talked about instruments. So kind of a completely different topic. And I think once I'm finished with these slides, we'll have to decide whether we're going to just try to kind of speed up the schedule, maybe leave more time for this afternoon, or whether I'll fit those in. But just to give you a warning, if I do go to those, I didn't make the slides available yet, but I will make them later. Okay, so a common use of empirical demand models to compute welfare gains. I'll focus on the introduction of new goods, just because that's kind of been the focus in I/O, but you can think of doing this for a lot of other effects. You know, mergers or regulation is a common theme that you might be interested in I/O. You might want to actually compute a price index, again, just like what Ariel talked about last time. So, but the basic idea of all the stuff that I'm going to talk about applies to all these other events. So in this lecture, I'll really cover two main topics. First, I'll start by a paper by Jerry Hausman that actually looks at the valuation of new goods and estimating demand in product space. And I think that will serve several things. First, it will kind of set us up on this whole idea of looking at welfare, but it also show us, at least, you know, we have one set of numbers that are coming from a slightly different demand system than the one that we've talked about. So we talked about demand in product space, but we didn't devote too much time to it. So here we'll see just one example of that. And then also it will serve as a comparison to the last paper that I talked about yesterday. So again, we could look at two different set of estimates for cereal and see how they compare. Okay, and then after I'm done with that, I'll talk about consumer welfare and discrete choice models and how we do that. Okay, so this is a paper by Jerry Hausman that was published in an NBER volume in 1996. What he proposes here is a method to compute the value for new goods under perfect and imperfect competition. And what he's going to look at is at the value of a new brand. Right, so the background from this fits exactly into what Ariel talked about last time. It's really the Boskin Commission that looked at the CPI and said there's a, why does this keep jumping? So, the Boskin Committee looked at the bias from the CPI and said there's a significant bias due to kind of omitted new goods, right? So that's exactly what Ariel talked about. And I think they put the value of the bias about 0.7%. I think that was the number that Ariel had on his slides. So I think what Jerry kind of tried to do in this paper is to actually show, yes, this is a problem, but it's actually a much bigger problem than what you thought. And what he took is what, you know, some people might consider kind of a trivial, you know, introduction. Say, you know, apple cinnamon Cheerios. I mean, what are those? They're basically just Cheerios that have been around forever with a little bit of apple and cinnamon sugar flavor tossed on top. I mean, that's not, when we think about innovations, we think about iPads, we think about iPhones, we think about, you know, CT scanners, we think about, you know, maybe minivans, right? I mean, these are big innovations. I mean, come on, apple cinnamon Cheerios. But, you know, Jerry will actually show us that there's a lot of consumer welfare generated from apple cinnamon Cheerios. And it's, I think, in some ways surprising, and in some ways, once you think about it, maybe not at all surprising. But I don't know, we'll get back to that. So the basic idea of what he's going to do is the following steps, or at least that's kind of how he presents it. There's different ways you could look at it. So he's going to estimate demand. He's going to use a particular demand system that we kind of mentioned in passing, and I'll go over the details of it. He's then going to compute what he calls the virtual price. So the virtual price is the price that sets demand to zero. Right? So you basically ask, you know, what price will basically make the demand go to zero, right? And we'll treat that as if that was the price pre-introduction. Okay? And then he says, I'm going to use this price, and then I'm going to plug it into whatever calculations you want to do, right? So if you want to compute a price index, use a Las-Peyres index, or use whatever you want, I'm just going to put that in, right? This is the price of the product before it was introduced. Okay? That's what he means by a virtual price. And he's going to do that under both perfect and imperfect competition. The difference between the two is, in one case, he basically holds all the other prices constant, right? And that's the perfect competition. And the imperfect competition says, well, all the other prices are going to respond, so I have to take that into account as well. So I have to compute, in some sense, what would be the prices of other goods when this virtual price was in there, right? And that's what he's going to try and do here. Okay, so the data that he's going to use is similar to data to what we saw last time. It's going to be scanner data for ready-to-eat cereal. He's going to have it for 7 cities over 137 weeks. A lot of what he actually uses monthly rather than weekly analysis, but that's the data he has. So it's a very similar data structure to my paper that we talked about yesterday. The one key issue here, or two key issues that came up in some of the discussion that follows. One is the fact that this is much higher frequency data, okay, and that's going to be a little bit of an issue when we talk about the price variation and what we're actually going to get from it, although I'm not going to do much with it. And then the other is the fact that he has no advertising data, and that came up with some of the comments that followed on this paper. Okay, what's the model that he uses? He uses this multi-level demand model that we again kind of mentioned in briefing. So what he has here is he has 3 levels of demand, right? So it's a little bit like this the structure that we have in the nested logit, although it's kind of actually an underlying different demand system. So you basically say you're going to take all the different products, and you say at the upper level there's demand for overall category, for cereal. Okay? Then below that there's demand for segments. Okay? So he's going to take all the cereals and separate them into 3 or 4 different segments. Okay? So that's going to be one, and then he's going to model the demand for each of these segments. And then within a segment, he's going to model the demand for each of the products, right? So there'll be typically about 5 or 6 products within each segment. So he solves the dimensionality problem or the too many parameter problem that we talked about last time by basically kind of setting these groupings, right? And what he does is within each group, he's going to allow for a flexible demand system, okay, in product space, okay? So let me try to unplug this thing here. I don't know if that's, it seems like, okay. So he's going to have a flexible demand system within each of these groupings and then kind of move up. So let me kind of show you the details of how that's done, because there's a few kind of fine tuning. So let me start with the lowest level. So this is demand for brands within a segment. So what he's going to have here is the so-called almost ideal demand system. So this was proposed in 1980 by Deaton and Mullerbauer, and 1980 was kind of pre the AIDS epidemic, and you could imagine, these days I don't think we would have actually used that acronym for the almost ideal demand system. But basically what this demand system does is you regress the dollar share of expenditure on a particular brand in a particular market, right, on basically the log of the prices of all the goods. Okay, so you have here, J sub G are basically all the products within the segment. Okay, and you can actually show, and that's what Deaton and Mullerbauer show, this is actually a flexible demand system. It can actually approximate to a second order any utility function. At least that's kind of the claim. It also, one of the reasons people like it is the fact that it actually has good aggregation properties. So you can actually start from individual level demand and shows that it aggregates well. Okay, so this belongs to the Gorman form family that Ariel talked about last time. Okay. The other thing that it has, the first term here, this YGT, these are the overall per capita segment expenditure, and they're divided by a price index, right? So if you just think of this kind of as a classical demand system, right, we typically in the classical demand system have an income effect. So that's kind of like the income effect here, but it's really coming from the fact of how much was actually allocated to this segment. And the basic idea, kind of to try to motivate what he's doing here, Jerry will sort of allude to ideas of multi-stage budgeting. So the idea is, a consumer is sitting there and deciding how much am I allocating to cereal. And then within cereal, how much am I allocating to each segment? And then within each segment, I'm going to make this choice within each brand. So I'm not going to go through the full theory of that, but in order to, there are some theoretical restrictions that you need in order to justify that. And for the most part, they're not going to be satisfied by his by the specifics here, although it seems like it doesn't, empirically, it's not a big deal. So if he made the changes he needed to do that, it seems like it wouldn't make a big deal. But in terms of the price, price index that he uses, excuse me, you can use one of two things. You can either use the, let me start with the second one, the exact price index. So this is the one that's dictated by utility. So if you literally said, okay, this is the consumer's demand, and there's an underlying utility that, that's behind it, you could say this is the utility consistent price index. Or you can use a much simpler version, which is the Stone price index. The advantage of the Stone is that then, there's no parameters in it, right? So therefore, it doesn't, that problem stays the linear estimation problem. If you want to use the exact price index, you see it has the gammas in there, and those are the same gammas that are up there. So now it introduces parameters, right, in that price index and makes the estimation nonlinear. So obviously using the Stone price index is a lot simpler, and it ends up, people have tried both, and for the 2 or 3 examples that I've seen, it seems like it doesn't make a big difference, so people usually use this price index. Okay, so that's going to be at the level of the segment, and he's going to have 3 different segments, and he's going to estimate it flexibly within each segment. Then what he goes up is he goes up to a middle level, which is demand for segments. And here what he has is he has to first construct a price, right, for each segment. Well, that's going to be this exact price index that we talked about. Okay, so it's going to be what's the price of the segment. That's going to be this these terms here. And then there'd be the equivalent of the income effect, and that's going to be how much you've allocated to that segment, kind of from the higher level. So here he's going to look at, it's going to be a log-log demand. In principle, he could have also done sort of an almost ideal demand system. Again, there's some issues theoretically kind of lining this up, but I think it's easier just more to to think of this as saying, okay, we're not exactly lining up with the requirements of economic theory and multi-stage budgeting, but we're just going to try and do this flexibly. And then finally, this is the upper level. Again, a similar idea of the total quantity of cereal that you bought as a function of some price index. That's that pi over there. Some exogenous, some demand shifters, and here you'll actually have real income. Okay, so that's basically kind of these 3 levels, right? In terms of substitution patterns, right, what you'll get is, right, there's going to be flexible substitution patterns kind of within each segment, right? And if you want now to have substitution between segments, you basically have to work through the middle level, right? So if you have, let's say, a brand like Cheerios, which is going to be kind of in what I think he calls the all-family Cheerios, and then there's going to be another segment where there's kids, let's say Fruit Loops, right? You want to see the substitution between them, you have to kind of basically work through the fact that as I change the price of Cheerios, okay, there's going to be a little bit less demand for that whole segment, okay, more demand for the kids segment, which would then change the demand for Fruit Loops, right? So you're going to have to work kind of through that loop, and you can work through all those details. In terms of estimation, it's relatively straightforward. It's usually done kind of what I call from the bottom up, or you can do it all in one stage. Depends again on the how you want to have the price indices. In terms of IVs, what he's going to really use is this idea of using prices in other cities that we talked about last time. Okay, so let me just kind of show you some of the numbers. I'm not sure if you can see. Let me try to. Sure.
So when you do that, when you want to look at the substitution,
Mm-hmm.
then all the demand for all the other goods change as well? Are you looking at like a new equilibrium?
Sorry, could you repeat? When you do the no, for the elasticity, it's just going to be well. You're going to look at the partial effect, right? So you say I'm going to, it's not the new equilibrium. You're holding all the other prices constant, right? Because that's what we do when you do substitution, right? Is you say I'm going to hold all the other prices constant, just change the price of Cheerios, and so I am going to let, in principle, all the other demands change, but not all the other prices. Yeah. So the demands, yes. I mean, you're basically saying, what's the derivative of Fruit Loops with respect to the price of Cheerios? Right, so the way you compute it, sort of, it's through the top. It's all through derivatives. You don't actually compute as a first order condition. Okay, so let me show you. These are the estimates. So generally, if you have the notes from last week, you can actually, or from yesterday, from yesterday, you can actually compare to what we got from a discrete, or what I got from a discrete choice model. But if you don't, you'll have to take my word for it, which is always a mistake, but you'd have to do it anyway. So one thing is, if you compare these numbers, the own price elasticities are roughly comparable. I think these are maybe a little bit lower than what I got, but they're roughly in the same kind of ballpark, which is kind of the typical for what we get for these products, which is basically between -2 and -3 or -3.5. I mean, that's roughly the ballpark of what I was getting, and that's, I think, what he's getting here, right? So the exact patterns might differ a little bit, but they're roughly in the same part. Where the main differences are in the cross-price elasticities. Generally, the cross price, if you just look at sort of the average absolute value of the cross, they'll actually tend to be a little bit higher. But the other thing that's always very striking here, and it's actually not unrelated, is you'll actually see quite a few, and that's kind of, I'm stressing, you'll actually see quite a few negative cross-price elasticities. Okay, so this suggests negative cross-price elasticities suggest that these are complements. Okay, so for example, this one here are Cheerios and Rice Krispies. Right, so if you say the price of Cheerios goes down, let's say, you're going to consume more Rice Krispies. Okay, now this particular one is not statistically significant. So you say, well, it's really zero, and we have so many numbers, it's not surprising that it wouldn't be. But one interesting thing with these, and let me actually scroll to a particular one here. Let me just see. Sorry, I need to. Okay, so what I want is Raisin Bran. So this is post Raisin Bran, and I want to see with the Kellogg Raisin Bran column. Okay, so that's right here. That's this number right here. So you see, this actually is negative and statistically significant, actually quite high. And so unlike the others where you could say, well, it's really what we got is zero, here you actually get a pretty strong negative. Right now, you don't have to know a lot about cereal to sort of say if you have a prior about any one of these parameters, it's probably that one. Right, to say, I mean, some people actually think these are homogeneous goods, should be perfect substitutes, okay, unless you actually eat Raisin Bran, and then you say, no, if one has more raisins than the other, and actually they do taste differently. I forget, one of them has more sugar than the other, so people that like one tend to actually not really like the other, but they're definitely not complements, okay, and that's actually a common problem with these. There's to give you another actually cereal-related example, but actually from a court case. So there was a merger. Post bought the Nabisco cereal lines somewhere kind of mid-90s, and the federal authorities let the merger go through, but the state of New York decided to fight it in court. So the court proceedings, as far as I know, I actually had nothing to do with it, but as far as I've heard, were basically about an argument of the cross-price elasticity between Nabisco shredded wheat and post grape nuts, okay, defined as a segment of cereals that kids would never eat, okay, would never touch, even if you forced them, right? So that was kind of that segment that people looked at, and it ended up that the state's expert, okay, objecting the merger, found a negative cross-price elasticity, right? So if you literally simulated the effect of the merger, okay, what you would get is that prices would decrease if you took your simulation seriously. It's kind of hard to make a case against the merger where you're saying, the merger would decrease the prices. And they try to wave their hands and try to get around that. So that was kind of and it's a very common problem, I think, for people who've used this to say that you tend to find negative elasticities for exactly those products where you have kind of a very strong prior, that they're very strong substitute. So what's going on with this? So let me just go back to the equation here. In part what's really going on here is the fact that, what we're regressing is some measure of quantity, here it's expenditure, on a bunch of prices. Now remember, these prices, especially of close substitutes, are going to be moving together very closely. Okay, and there's a lot of reasons why they could be moving together. They're subject to common shock cost. They could be moving together because of that. They could be moving together because of they're responding to common demand shocks. Or just because of the way that they're competing with each other, right? All of these will sort of tell you these are going to be very highly correlated. So it's actually going to be very hard to separate, to tease off the own effect and the cross-price effect, okay? And in some sense, that's what the instruments are supposed to be doing, and maybe this is just another way of sort of saying, you know, there's potentially a failure of the instrument and actually getting at this. So that's kind of one potential concern. It should, but well, if it's just a pure failure of the instruments, then no. I mean, right, if the instruments are not valid, then you could say. If it's some sort of something of saying, okay, there's kind of some combination of, you know, an IV version of multicollinearity, then we think we could. Although, you know, I've always thought, never proved it, so, you know, this might be completely wrong, okay, or there's a pretty high chance that what I'm about to say is just completely wrong. But I've always wondered if there's actually some version of the same problems that we see in weak IVs, right, where you think, okay, if you have a weak IV, you know, that should show up in the standard errors. And we know that actually when we have a lot of weak IVs, the usual asymptotic approximation standard error is very poor. So if you do alternative asymptotic approximations, yes, it will show up there, but the standard way we compute standard errors doesn't show that. So I don't know if there's something like that here. I always thought there might be, but, you know, I've never actually looked at it more deeply. But you're absolutely right in the sense that what we'd expect, our first prior is that, you know, if there really is this fact of kind of this IV version of multicollinearity, then it really should be showing up in the standard errors, and it's not. So I don't know what's going on, but, you know, this is not just one random, okay, I found, you know, the one number doesn't work. That's a pretty consistent pattern that you see. And if you talk to practitioners, that, you know, this is often used, and I think, you know, Dennis could probably second me that, you know, in a lot of actual cases where this is used, you know, it's a problem, because that's exactly the number, the one number you care about in many cases is exactly the number that you don't feel you can rely on, and that's a problem for this. Okay, but putting that aside, so that's kind of in terms of the comparison and seeing, putting that aside, now let's go to the welfare. So basically what Jerry found is actually under perfect competition, he approximated that Apple Cinnamon Cheerios added almost 80 million per year in the US in terms of consumer surplus. Once you have imperfect competition, you need to basically try to simulate the world without Apple Cinnamon Cheerios. So what he did was assume a Nash-Bertrand model, which is kind of common in a lot of what we do. I got right here ignores the effect of competition because he actually didn't really compute the new equilibrium. You can think of it as he did like a first order approximation to it. The way he did it initially wasn't quite right, and that was pointed out. So initially he found that with competition was a little bit less, about 67 million per year. He actually later corrected that number, and it was about something like 40 million. And then he extrapolates from this to the CPI, and he claims that, you know, the bias is much, much larger than what it was before. I'm not going to go exactly how he does this extrapolation, but that's kind of basically the bottom line of what he does. He claims that the bias is much larger than what the Boston Committee found. Yes, Dennis? Yeah. Mm-hmm.
Basically, this kind of symmetry very poorly at satisfying what we think of the underlying. Right? So, is it your view we should impose those conditions as many people do, and forget about the fact that you would reject them in the data, or not? I mean, it kind of always makes me a little nervous when you get something rejected that when you're building it up from a utility
right.
function.
So let me step back a second. Just put. Yeah.
And then the comparable question would be in sort of DLP, what the corresponding problem is. Is there one?
Right. So let me step back a second, and so I'll take these kind of separate. So the first question is imposing restrictions of economic theory. So originally, Dietten-Muller-Bauer, one of the advantages of this almost ideal demand system is actually very easy to impose restrictions, like adding up restrictions or symmetry conditions, because they're really all just on these parameters. I didn't actually go through the whole detail, but it's very easy to impose. And indeed, the original model, so the original Dietten-Muller-Bauer, was not, you know, for these types of products. It actually was much more aggregated. So there, you know, a product was housing and clothing, and so they were looking at kind of, And you're right that there was actually a kind of a large, literature kind of in that, in the 80s that was looking at this. And for the most part, they found that if you impose, you could not impose the restrictions and then impose them and test. And when you did that, you found that the restrictions of economic theory were not met. Right? And I guess there's several ways of looking at it. I mean, consistent maybe, if we look at sort of some of the theme of what Ariel was talking about yesterday, you could say maybe that what was rejected was not necessarily economic theory, but the aggregation conditions required to get to this system. Right? So that's one interpretation of it. Another interpretation, which is also, it's a different form of aggregation. So there's aggregation across consumers, right, in the Gorman form that needs to go into them. There's also aggregation across product that was especially prevalent there, because if you're talking about housing, I mean, that's aggregating across product, clothes or food. I mean, that's all. So, so I think, it's literature way before my time, but my reading of a lot of this literature is that people basically said, it shouldn't be a surprise to us because really what's failing is this aggregation across product, okay? Which is very different, than what we have here, because here we're at the product level. Now again, a product here is Cheerios at a city level, right? So we're still aggregating, obviously across individuals, but also across products in terms that there's different size boxes of Cheerios, different stores, right? There's Walmart's actually not in this data, but you can think of, having, I don't know, 2 different supermarkets that maybe have very different prices, some on sale, some not on sale, so there's all that going on here, but there's much less aggregation. And I think, this is just my impression, although I haven't, is that it tends to be, I think, that imposing the restrictions, they fail less here, but you are right that they do fail quite often. And I think it's, I don't want to say it's like generally, oh, you shouldn't impose it or you should. I mean, I think it really depends on the case and what exactly the product is and but I share your concern that if your results are driven by imposing the restrictions, then you have to feel very, very strong about the aggregation that's underlying them and to really think, okay, I really think this is a structural demand system, right, from a representative agent, because otherwise you shouldn't impose those restrictions.
Right.
Okay?
One question, I've seen the tests in the AIDS setting. What about in the DLP setting?
Right, so let me actually kind of take that a little bit further back and be a little bit kind of clear. So let me kind of put in the context here, and you'll see in a second how I'm going to. So one of the things you might sort of say, it's like, oh, wow, great, here we had these, we freed up the cross price that we got negative, but, we went to the BLP world or the discrete choice model, and, we didn't get any of these negatives, therefore they're superior. One has to be a little bit careful there, because in some sense they're almost by assumption. Okay, I mean, it's to get a negative cross price elasticity there. So in a logit model, okay, pure logit, no heterogeneity, the only way you can get a negative cross price, you basically can either get all these numbers right, of the right sign, or all the numbers of the wrong sign, because they're all driven by one single coefficient, the price coefficient, right? That's not true in the random coefficients model. Now you have a distribution. So it could be, as long as part of the distribution is in positive, and part negative, you could get that some of these are positive or not, but it's very, very rare. Like, I've never actually seen that happen in actual estimate. But it is coming, partly because you're in some sense imposing, the conditions of economic theory, they're kind of built into the model. Okay, so it's not like arbitrary statistical assumption. It's going through the conditions of the model and saying, we have this marginal utility of income, right? And therefore, in some sense, we don't have all these kind of other prices statistically showing up. Ali, do you want to add something? Yeah, I mean, the other 2 things to look at, and I kind of try to highlight, yesterday, is A, kind of look at patterns of elasticity. So we typically, I don't know, in cars, my intuition is that demand for more expensive cars is less price elastic than demands, or so that you want to look at that. And sometimes I find much more useful than looking at the elasticities is looking at the implied marginal cost. Right? Because you want to actually see, what are the patterns, and a lot of times when you go to test these models, that's how we test them, we actually bring data, but even if you don't bring data, you have some patterns of saying, I think it's a lot more expensive, I'm quite sure that it's a lot more expensive to produce a Mercedes than it is to produce a Civic, and any estimate that would not give you that, you probably shouldn't trust, right? Similarly, if you look across different products, you might want to say, well, let's compare, I didn't show you, but let's compare what's the cost of producing, the implied cost of producing, let's say, cornflakes versus frosted flakes. Okay, frosted flakes should be a little bit higher just because of that extra sugar, but there shouldn't be completely different. So sometimes that's the better way, I think, formally that's also how we test these models. But in there is not just a demand, it's also a supply model to get the cost, as opposed to just looking at the elasticities. Okay, so that was Hausman's findings. There was kind of a follow-up about 10 years ago, so just kind of following that discussion, there was actually, if you ever needed proof that economists are bored, you could have followed this discussion. So it ends up, in this volume, there was actually discussion by Tim Bresnahan of the paper, and then there was some back and forth between Bresnahan and Hausman about, who said what when and what appeared in writing and who showed what and whatever. I mean, if you're bored or you have a high utility for these things, whatever, I think Tim Bresnahan still has the whole exchange because a lot of it was in writing, back and forth. Still has the whole exchange, I think, somewhere on his webpage. But again, if you're bored, you could look at it. If not, it's not. But in terms of what the actual substance, kind of putting around all the theatrics around it, I think there was sort of two kind of issues. First, I think, and that was kind of intuitively. This goes back to the point I kind of said earlier. People would have said, well, you think about innovation, you think about new products, you think of exactly the type of products that Ariel talked about yesterday. You think about TVs, you think about computers, right? That's where the innovation is. It's like Apple Cinnamon Cheerios, come on, give me a break, okay? But I think what Jerry, is making a point here is saying, if we want to really take our model seriously, I mean, this introduction was a big deal. I mean, it got over a 1% market share in an industry that's very hard to break into, in a fairly mature industry, right? And they were actually selling at, fairly high prices. And, this basic demand system just translates that. So, people say, well, $80 million a year sounds like a lot of money. But if you think about this is a $9 billion a year industry, right? Just in the US. So I don't actually know if we really should be surprised. But I think underlying this kind of objection was the fact that people just thought this just can't be right. But I think, putting aside whether the specific numbers are right or not, I mean, I think, there is something here. There's, like it or not, there's innovation, right? And there's innovation because people are buying it, right? And there's some sort of consumer surplus generated by that, and we have to take that into account. In terms of the analysis, there were sort of two issues that came up. One has to do with instruments, and basically the point was that since there's no advertising data here, right, and remember the requirement for these instruments to work is the fact that we talked about it yesterday, we need the air terms to be independent across the different cities, but if there's national advertising, that will create a correlation. So that was one of Bresnahan's points, but indeed, actually, once you put in advertising, it doesn't seem like it changes the numbers a bit. And then there was this issue of the computation of the Nash equilibrium, and indeed the way that was initially done wasn't quite right, but when you do that, the numbers go down slightly with the competition, but it's still, I think it goes from 60 to 40 million. Yeah. Well, I think right. So I think if you wanted to do the total welfare, you would. But if you just want to do consumer welfare, you just say, I introduced this product. How much gains did I get from consumers? And you're right. If you want to do total welfare, you have to take that into account. But I think here we're focusing just on the consumer side, right? So for that, I mean, you can just look. And remember, if what we care about is the CPI, right? Which is CPI again. It's the same. We're not looking at PPI, we're not looking at just a CPI. I mean, I think that's the, so that's the argument here. So you could be right, and I think that's implicit in a lot of the argument, saying, well, yeah, there's a lot of welfare loss here, not consumer, but total welfare, because we're not generating a lot of benefits with this, with these new brands, but we're spending all this R&D, and that's waste. But that's, I think, slightly different than what I mean. Hausman's numbers definitely speak to that, and I think he's going to challenge the first part of it, saying there isn't a lot of benefit, because it seemed like there is, but whether that's enough to cover the quote-unquote wasteful R&D, I don't know, because we'd have to look at that. Yes?
His analysis also seemed to exclude the generic store brands that often
Yeah, during this time, actually, they weren't a big deal, and they definitely were not a big deal for Cheerios. So, if we were actually to do this for, not that cornflakes introduced, but if it was like apple cinnamon cornflakes, I don't know that these were actually, well, they maybe tried them, but I don't know if they were ever successful. That might have been a big deal, but actually Cheerios is one of those products that very few people have been able to imitate, so the store brands are actually not a big deal for Cheerios. But in general, you're right, but I think it's for the specific numbers that he had, I don't think it actually matters. Okay, so that was Hausman. So now I'm going to go and say, okay, suppose we wanted to do a very similar exercise using the,
Why would store brands alter the suppose they were store brands, you would still estimate a downward sloping premium curve, calculate the surplus, and find the mean document. In other words, as long as the store brand is also a new product, or even if it's an existing
No.
product,
I mean, the way I understood the comment, maybe I misunderstood, was the fact that, his numbers are biased because he omitted store brand, and therefore his demand numbers are, now we could try to work which way it would bias, but I don't even think it's worth going, because I think Cheerios is, generic Cheerios are not a big deal, so I doubt that it would actually matter for these numbers much. But that's the way I interpret the question, is that the demand system, in some sense, you get the wrong demand system because you forgot an important product. Yeah. Yeah, you could, but he didn't do that. I think that was the point, and the question is, and I conjecture, again, knowing a little bit about this industry, that it would have done very little. So I think that's kind of my answer. But yeah, but in principle, you're right, omitted variable. But again, you could say, what would that bias do? The instruments take care of it, and not. But I don't think it would have mattered for his bottom line. Okay, so now what I'd like to ask is suppose we want to do a similar exercise using the discrete choice model. Okay, we're not going to actually do it, for cereal, but kind of the same idea of kind of introducing in a good. So in order to do that, you might sort of say, well, we know how to do consumer welfare in product space. How do we do that in discrete choice model? Well, it ends up this was actually worked on fairly early on by McFadden, and then there's a paper by Rosen and Small, kind of early 80s. And basically, the key to this is something called the inclusive value, which I'll define here. So let me just remind you the notation. So the notation I have, utility IJT is this XJT beta I plus price enters in a linear way. So we're going to define this thing called the inclusive value, sometimes also referred to as the social surplus, is the following. So this is from a set of alternatives. So you can think of, if I want to drop, just say the whole set, everything, then so what you do is you take the log of the sum of summing over all the j's, all the products that are in this alternative, of basically the exponent of the utility. Okay, and so that's what we're going to call the inclusive value. Now it ends up that this inclusive value, that's really the expected utility from these options prior to observing the epsilons, right? Prior to observing those epsilons over there. So if I'm actually sitting and saying, okay, I'm going to get a set of options. I know that I'm going to get, I know the utility for each of these, or the utility, I refer to utility, I should really refer to the part without the epsilon. Okay, so I know exactly what I'm going to get without the epsilon. Okay, and I said, but I know I'm going to get these IID draws, one, and B, I know that I'm going to choose the product that's going to give me the highest utility. Now utility is with the epsilon. Okay, but I don't know what the draw, and I know my utility is going to be a function of this epsilon, right? So I have to say, what's my expectation? Right? Knowing that I will make the choice in this way, well, it ends up, that's exactly this formula, right? So this is basically what, if you want, the expected, or kind of the utility that I get times the probability that I actually choose that option, subject to kind of the model. Okay, so that's what this thing gives, and it's actually not that hard to show, but it usually involves, you kind of want to do a transformation of variables when you compute that integral to the uniform. It's actually a pretty simple calculation, but it always takes me kind of a day or two to actually, whenever I sit down, actually do it. Now, if there's no heterogeneity, okay, so this is in the pure logit model, just as an example, then it ends up that the inclusive value is going to capture the average utility in the population. Okay, so it's actually equal. So this is now x post or x ante because of this, this no heterogeneity. With heterogeneity, basically what we're going to say is, this is kind of the average. So this is basically for each individual, if we don't know their epsilon, right, if we want to integrate over the epsilons, and now we have to integrate over the individuals, and typically we have to do that numerically, right? So what we'd have to do is you basically, okay, this is for each individual, and now let's integrate over these, distributions of the demographics and the other unobserved variables. If utility is linear in price, the way it is here, then if we want to turn this measure into a dollar measure, we just divide by alpha I, right? If it's nonlinear, we have to do it by simulation. Okay, there's actually no closed form solution to actually converting this into a dollar metric. Okay, and there's just slightly different ways of how to do the simulation, but I won't go in them. So I'm actually going to stay, for most of my discussion, they stay in the quasi-linear world, right, where price enters in a linear way, and then we can easily convert this to a dollar. Okay, so you see this is actually, fairly easy. It's really just this kind of log sum formula. Okay, this log sum formula, let me tell you, it's actually one of the most useful things to know when you're kind of working with these logit-based models, because it it comes up in various ways, right? So remember yesterday when we talked about estimating nested logits, part of what I said, you estimate it at a lower level and then compute the expected utility, which is just this inclusive value, and then look at the choice basically between segments based on the expected value. Later today, when I talk about dynamics, it's going to end up that's going to play a key role in simplifying kind of some of the state space. Okay, so it's a very important concept. Okay, so applications of this. One of the very first applications, at least that I'm aware of, at least kind of in this I/O literature, is a paper by Manuel Trachtenberg that came out in JPE in '89, where he actually estimates a nested logit model and uses it to measure the benefits of the introduction of CT scanners. Okay, I'm not going to go through his numbers in large part because it's actually quite hard to interpret them, because this is actually pre-BLP. So what he gets is when he actually estimates his demand system, he gets a positive price coefficient. Okay, so consumers like higher prices, and because he didn't control for the endogeneity of kind of this unobserved characteristic. So it's a bit hard to do welfare analysis when you have an upward sloping demand curve. So basically, what he did is he does some sort of hedonic correction to do the welfare, and it's kind of funny to read it through it now that we sort of know how to quote unquote do things correctly, right? They don't know. Okay, we should have instrumented for price and gotten the right price. But in terms of the idea, so the actual numbers, in some sense, I'm not quite sure are meaningful right now. But in terms of the actual idea, the exercise was there. Emil Petrin, in a paper that was also published in the JPE, did a similar exercise, but now actually, this is post-BLP, so kind of done right. So what he did was he did the BLP, used the BLP data to repeat this and look at what are the welfare gains from the introduction of minivans. Yeah? So one of the main things that he did compared to BLP is he actually added what's called micro moments to the BLP estimates. And I think Ariel is going to talk more about how to add micro moments later today. So I'm not going to talk about it. And he talked actually a little bit about it in the beginning of the last lecture yesterday. So the basic idea is you're going to bring in some information about consumer choices to help you pin down the substitution patterns. And indeed, once he did that, the predictions of the model were much more plausible. And he attributes this to basically, this is literally a quote, that the microdata appears to free the model from a heavy dependence on the logit error term. Okay, so that was sort of his conclusion. So let me actually show you just his numbers, partly his kind of motivation. We've kind of had, I think, this theme that whenever possible, try to use microdata, and this might actually be an example. And then I'm going to actually use that to talk about the welfare numbers. So here, this is his table 5, where he estimates the parameters. And there's 2 columns here. The first column is with no microdata. So think of this as basically the original BLP. And then the second column is adding microdata or micro moments from the consumer expenditure survey. Okay, and the key, we can look at sort of different ones. Maybe, the thing to look at is, I think the key thing, rather than looking at any specific numbers, is to basically show that you can see the first column, many of these numbers are not very significant. Okay, these are basically the random coefficients, right? So it basically says, we're not that far away from the logit, at least in terms of, statistical. But once you add the micro moments, they tend to actually become larger in magnitude and much more significant. So it really helps pin down the kind of the distribution of the heterogeneity. Yeah, I'll talk. That's going to be the rest of the talk. So yeah, yeah. So I'll talk exactly. I mean, that's going to be okay. So so I think the key thing to take from these numbers, and more generally, and I'll yeah, actually let me show you kind of the welfare, and I'll kind of then conclude. So if you look at, he does the welfare here, doing just if you do it with logit, if you do it with IV logit, random coefficients, and the random coefficients with microdata, and you basically see, I mean, he computes here, this is this compensating variation, so basically these kind of welfare measures. Because it's a nonlinear model, it has to do it a little bit differently than what I showed there. It has to do it numerically, but that's the basic idea. You can see that the more and more heterogeneity you add, right? So you start from, well, this is just, here there's just a matter of bias, but just from here, the more, once you add random coefficients, these numbers go down, okay? And once you add the micro moments, they go down even further, right? And so the basic idea, right, is as you're expanding more and more, there's more and more heterogeneity, and the heterogeneity is coming from the random coefficients as opposed to the logit error term, right? So I think that kind of leads, Dennis, to kind of to your question, to basically say, as you're kind of moving further and further away from the logit model, the welfare numbers go down. And I'll see in a second what I tell you by freeing up. I mean, that's exactly going to be the discussion. Okay, so it makes a huge difference for the actual estimates of the welfare, but also makes a huge difference for everything else. I don't have time to kind of show you that, or I didn't, paste this to show it, but it really makes, adding the micro moments really makes a big difference. Okay, so one very important conclusion to kind of take away, so whatever you take away from today's lecture is, a theme that I hope you've heard over and over again over these lectures, whenever you can get microdata, okay, whether in the form of moments like you have here, whether it's variation across markets, whether it's second choice data or anything of that sort, it's extremely helpful in pinning down the distribution of random coefficients. Okay, so that's, I think, one very, very important lesson that's kind of we've taken away from this paper, and that's important that you take away. Okay, the second point has to do now with the welfare numbers, and that's basically going back, Dennis, to your question. So so as I said, I mean, I guess the first point I said here. So now the question is, what's driving the change in welfare? Okay, what's this freeing up from the logit error term? So I think what Petrin means in his paper, and there's been some follow-up papers that have been a little bit, kind of more specific about that. So one interpretation of what's going on is the following. So welfare here, you can think of it as an order statistic, right? I mean, what you get is you get the utility from your highest option. Okay, so you basically put your hand in the bin and you draw out a random number, right? And that's a utility. Now, suppose there's just one number in that bin. Well, you get just one draw. Now, suppose you actually get to draw 10 things out of the bin and then look and say, oh, I want the one with the highest utility, right? Because that's what we're doing in these models, right? You get to draw an epsilon for each of the, for each of the options, and you get to choose. Then it's not that, okay, you draw it and then it's randomly assigned to you. You get to choose the one that's highest. Okay, so therefore, if we just, suppose we just very mechanically added options. Okay, so you said, okay, now you don't draw 10, you draw 11. Okay, or not 11, but 12. Or, not 100, but 101 by adding the minivan. This is going to be mechanically increased welfare, right? What I mean by mechanically is just the fact you get another draw of the epsilon. They're all IID draws, right? The distribution doesn't change, so therefore the welfare is going to go up, right? So that's what I think, he's referring to, is this kind of dependence on this, what was exactly the terminology here? This heavy dependence on the logit error term, right? And that's kind of one interpretation of what's going on here, right? Is to basically, as you're moving further down, you're in the logit model, you're basically, heterogeneity is only through that IID term, and you want to actually kind of, you reduce your dependence on it. Yeah. No, please continue.
Was that your error term had those summation of the B's and then the logit error. And then I had asked Ariel yesterday what happens if goods become perfect substitutes, and he explained that because the logit error does not. So is this a way of explaining that kind of you're assigning more of the variability in case to the stuff you can control and not just the dependence random draw?
To some extent. That's kind of what's going on. But why don't we hold on to that question and let's see, because that's exactly what I'm going to be talking about. Okay, so let me kind of tell you what I sort of think is going on, and I'm not sure if it's going to answer exactly what you have, but let's return to that. So if at the end of the slides I still have an answer, then we'll talk. But no, I mean, that's exactly, I think you're asking exactly the right questions, and please continue to ask questions, okay? And anyone else, if you have, please stop me, okay? So basically, it's a mechanical increase, and as we increase, the variance from the random coefficient, in some sense we're putting kind of less and less weight on this effect. So that's a little bit of what you're saying, and that's kind of the interpretation of what was going on, okay? So that's one option. I'm going to have a different take on it, okay? So maybe this is kind of my answer to you, Dennis, and let's see, I'm going to go through quite a few slides here, but let's see if I can, if that will answer your question. So the analysis here has two steps, right? Both the analysis that Petrin did and the analysis that Hausman did and others. So the first step is we're going to simulate the world with or without minivans, right? So it depends kind of where we start. You can start with a world where we saw the introduction of minivans and said, which was, I believe, 86 or 85. But we see in that year, what happened, and we said, what would this year have been like had there been no minivans, right? We need kind of the but-for world or the counterfactual world, right? So that's the first thing we need to model for, or that's the first thing we need to do. Then what we need to do is, after we've simulated prices and quantities, we need to somehow summarize them into welfare, right? Because welfare is not something we observe, right? We need a model to compute welfare, right? So even if for whatever reason, suppose we wanted to do kind of, a diff and diff or something of that sort, right? We could do that on prices and quantities, but we still need a model to summarize welfare, right? So suppose, minivan was only introduced in, on the West Coast and not on the East Coast. And we could sort of say, okay, that's going to create some way for us to create kind of a diff and diff estimate of what the prices and quantities would have been at the West Coast, was it, but for this introduction. Okay, we still need a model for the second step. Okay, so these are two distinct steps. Now, of course, if we do this diff and diff, maybe we can isolate the effect of introduction. You could also imagine just doing it, just as a diff, right? Just sort of saying, well, let's imagine if a minivans were introduced in 86, let's just look at, compared to 85, which in some sense that's what we're doing when doing CPI, right? But again, if we want to isolate just the minivan, we need maybe a little bit more. We need this diff and diff. Now, what I will claim, okay, what I will claim is that the Logit model is going to fail miserably in the first step. Okay, and that's in some sense a known problem, and that's exactly what we've been kind of saying all day. The Logit model is not very good at sort of predicting kind of what happens when you kind of throw in new options, right? Because of this IID kind of or kind of IID IIA properties that you get. But at least in principle, it can deal with the second. Okay? Now let me just sort of be clear. For the second step, I'll actually show you where it's going to fail is it's going to fail in the fact that it doesn't take heterogeneity in this welfare measures, right? That some people really gained a lot from minivans and some didn't. But actually, if there wasn't sort of this heterogeneity in the gains, the Logit model could actually get it right. Okay? So I'm not advocating for the Logit model. Okay? The Logit model is going to get you wrong here. I'm just advocating in the direction of which things could go, and I'll show you it could actually in principle go either way in terms of it could overestimate or underestimate the effect. And I'm trying to be clear of exactly where the failure is in which of these steps. Okay? So the Logit model, I'm not saying that the Logit model is the right model to use. It's quite the opposite. It's not. But we have to understand why it's not, why it's not working, right? So that's in some sense, Dennis, you see, going right, right at the kind of the heart of your question. So I'm going to demonstrate this by using this is an old example dating back to 1960 to De Breu. It's called the red bus, blue bus problem, and you might have sort of seen it in different places. Now, originally, this was used by De Breu to show kind of the IIA problem of Logit and to show kind of some of the problems that we have with Logit. And in some sense, it's going to be the worst scenario for Logit because we know this was used as an example. Oh, you see how terrible the Logit model is. Look at these terrible predictions that it gives. But I'll actually show you that there is a way in which to do welfare in this model that the Logit model could get things right here if there's no heterogeneity. Okay, that's the key. There's a big conditioning here, and then the heterogeneity. Okay, so let me tell you how this example works. So there's consumers here, and consumers choose between driving a car to work or driving a bus. I'm put red here in parentheses because at this point they're just a bus. Just to be clear, working at home is not an option. So there's basically I'm trying to eliminate. There's no substitution to kind of on the margin of whether to work or not. Right. So working at home is not a margin. A decision of whether you're going to work does not depend on the transportation. Okay. So it's really just this decision of the margin. Just do I take a car or a bus? Not any other margin. Okay. Suppose initially we start, half the consumers choose to drive and half consumers decide to take the bus. Now suppose we're going to artificially introduce a new option, okay? And we're going to call it a blue bus. Now why is it artificial? Because suppose our consumers are actually colorblind, okay? They literally cannot tell the difference between the buses, okay? Now we have to think a little bit, actually coming as IO economists, think, okay, what does it mean introducing a new bus? Even if it's the same color, I mean, maybe there's now more competition in buses, so the price goes down, okay? So I'm going to rule that out. Now maybe you say, okay, there's no price change, it's regulated, but maybe the bus is more frequent. Okay, so the option becomes, I'm saying no, there's no price change. So basically the idea is, you can think of it, we just painted half the buses red and half of them blue, but our consumers, they don't even know because they're colorblind. They can't tell the difference. Okay, so basically if we do that, given kind of all these stories that I've told you, nothing should change, right? Half the consumers should continue to choose the car, and the other half will split between the two buses. Basically in proportion to, I don't know how we color the bus or when they're coming, but you basically think half-half. And consumer welfare should not have changed. Okay? That's kind of the story. So now let's sort of say, suppose we wanted to evaluate this using the Logit model. Okay? So let me write a very, very simple version of this Logit model. I'm basically going to say the utility from IJT is it's now just this xijt. Okay? So I mean, just the unobservable, but think of it as just a dummy variable. Okay, plus this epsilon. So let me start at period t equals 0. Okay, and what I'm going to have here is I'm going to have the options, the share for each option, and what the implied psi is from those, and I'll kind of work back and forth. So first we start with 0.5, 0.5, right? That was the story of market shares. What are the implied psi's? Well, we need to normalize, so let's normalize the car as the outside option and say it's 0. Right? And because the market share is equal, the psi for bus at time 0 should also be 0. Okay? That's just, just coming from this normalization and the fact that they have equal shares. Okay? And to do the welfare, right, if we plug this into kind of this log sum formula, the welfare is just going to be log of 2. Okay? So that's pre-welfare. Now let's look at introducing this new option. And now I'm going to separate between the predicted, what the Logit model would predict, and what we actually observed if we actually had data. So let's start with the predicted. Well, now that you introduce a new option, you say, well, car definitely didn't change, right? So that should be 0. Okay, so here I'm actually going to work not from the shares, I'm going to work from the psi's and then figure out what the shares should be, right? So car didn't change. It was 0 psi before, so it's going to be 0 now. Okay, that's natural. Well, you attempted to say bus, red bus, was 0 before, should be 0 now, right? That's what the Logit model would say. I'm going to try to predict what the psi is of a red bus should be 0. And since red bus and blue bus are the same, it should also be 0. Right? So the psi's of all three should be 0, and then if I want to compute the market shares, it could be a third, a third, a third. Okay? That's what the Logit model would predict, and you would, of course, get this increase in welfare. And in some sense, they will cannibalize each other, right? That's what's, what the Logit isn't kind of doing right? And that's, and in some sense, that's what we expect, right? So that's the way you think, oh, well, that's what's happening when we're doing, using the Logit model in the exercise before, right? We introduced a total artificial option, and we got an increase in the welfare, okay? But now let's actually say, suppose, so that's where we use the Logit model for both steps. Now suppose we can actually isolate the second step. Okay, so suppose we don't need the model to predict. Okay, that we actually got to introduce the new option, and we got to see what happens. Okay, so we're going to eliminate the first step. So now, from the story I told you, we know that the shares are unchanged, right? So basically it's 0.5 for cars, and we just say, let's say we split this. A quarter and a quarter between the two. Well, I can compute what the psi's are that would give me that out of a Logit model. And whoops, wrong way. And that's what they are. It's 0 and then log of 0.5 and log of 0.5 for both of these. And guess what? When you actually do the welfare analysis using these, you get exactly the number that you got before. Okay? So it ends up that once we actually have this new bus, sorry, the ex post observed error, we can actually, in some sense, get the quote-unquote correct, correct shares, and then we put this into the welfare and we're going to get the right number. Now let me sort of emphasize, we're getting the right number here because there was no heterogeneity, right, in the valuations, right? Now if there was heterogeneity, the logit would potentially get the wrong number, okay, in the welfare, even if, it got the right market shares, right? So even if we gave it the right market shares, it would still get the wrong number, but that's because it's missing the heterogeneity, okay? So we need to kind of separate between the two things. Now, of course, what happens here, and one potential thing you could object to, is the fact that what we did was we said, well, I'm going to change the psi, right? I'm going to change the characteristics of the bus, even though the bus itself didn't change. You might say, well, wait a second, the option didn't change, so why should the characteristics change? You're kind of, that's not in your structural model. Why should you let the psi change? That's sort of not working here. But then we have to really sort of think about what we mean when we introduce the blue bus, right? And this goes back to this, these issues of, of the service. So if we literally just painted half the bus is red and half blue, well, then in some sense we did change the option, right? If before the bus, came to the bus stop 10 times a day, now the red bus only comes 5 times a day, so there was in some sense a change in the option, right? So it is justified to change that if you want, even from internally. But it does go back to something that was way back in the beginning of our slides, which is a lot of times when we want in these models, we want to do sort of predictions, we now have to take a stand on exactly what that psi is and how it's formed. And that's potentially, a problem for a lot of things, including, for example, if you want to do a merger simulation. You might ask, well, post-merger, what's going to happen to this psi? Right? And that's something that we need to take care of. Okay? So just basically generalizing from this model, what I claim is that the logit model fails in the first step. It could also fail in the next step, and I'll show you actually in a second the formula for it. But the idea that it's if you give it the market shares and there's not necessarily heterogeneity, the fact that it will get it right is actually more general, because the expected in the logit, the expected utility really just depends on the share of the outside good, right? So as long as you actually give it the outside good, you could actually get kind of the right numbers. Yep. So Petrin uses the equivalent, of the predict, right? So he used the model to predict the counterfactual and then do the welfare, okay? What I'm saying is, now in his exercise, you needed somehow to create what would have been the but-for world. So you could say in his exercise, it wouldn't have been practical, unless, again, you could do some sort of, I don't know if you'd believe a diff and diff or something like that, right? Well, he observes them post-introduction. He observed them pre-introduction, but in a different year, right? So suppose they were introduced, I forget if it was 86, but suppose it was 86, he observes 85. So if all that he wanted to do was compute a price index, and it's a point that I'll come to later, you could actually say he observed the pre, 85, 86. But suppose, you might say there's other things happening between 85 and 86. It's not all about minivans. Okay, so that's an assumption that 85 is the but for 86 without minivan. But if you're not willing to make that assumption, you need to introduce the model. Okay? So more generally, when we have heterogeneity, you might ask, well, how do these two things differ? Well, it ends up that really the difference in shares, right? So in the logit model, right, in all these models, basically this log sum formula is really just 1 over the market share of the outside good, or more generally the probability of choosing the outside good by I. So in one case, right, basically what we have, right, this is going to be the formula, right, which actually writing out, you could say I'm actually integrating over, if there is actually heterogeneity in the population, that's what this logit formula is going to equal to, okay? And in the other case, it's this thing here, right? So it's basically a question of, do you want to take the log of the ratio of the averages, or the average of the log of the ratio? Right? That's really just, and we know that, if this is the right formula, that's not gonna get it. And, which way it will go, right, really now depends. You can use Jensen inequality to actually sign sign the direction in which it will go. Right? So you can sort of see it's going to, potentially go in other ways, and it really depends on, how this outside share changes, right, across individual, or the ratio of these things changes, right? So how does heterogeneity in these things change over time, right? So basically, as we introduce these option, this outside, this kind of whatever event that we're trying to study. Okay. So let me just sort of final comments, and then, in some sense going back to kind of your question. So the key thing here was that we allowed, the Xi-JT to fit the data. Now, this will work well, or can work, when we see pre and post data, okay? Because in some sense, they tell us how to change the Xi-JT. Now, the question is, what happens if we don't have data on the counterfactual? We don't know what it is, so then we'd either have to make a model, of how this Xi-J is determined, maybe make some assumptions, and that's something that we're going to have to face when we're going to talk about, price indices. So, for example, we could do, various things, or we could try to sort of do some sort of bounds of saying, okay, I don't know exactly how it's going to change, but I can maybe bound it in particular directions and use that as well. And indeed, all these issues come up when you actually say, now suppose we want to actually compute a price index from observed data and using, estimated demand system. They all come up there, and there we do have the advantages, since we're not looking at a particular event, that we do see things change over time, right? But then it's a question of, well, what do we want to do with these Xi-JTs? Do we want to let them change or not? And it really fundamentally it fundamentally depends on what it is you think goes into them, right? So the example I gave said you should change, but then I can also give you examples where you don't want things to change. And it relates kind of in some ways very, very directly to the stuff that, and actually I only realized that listening to your lecture yesterday, Ariel, when you were talking about, the match model, right? Because it directly relates, right? What you do in the match model is you're saying, well, these things are constant, right? These Xi-J's are constant, and maybe sometimes you want to let them change because you're trying to keep, pick up, various elements in the environment. And so anyway, I think, that's still issues that we kind of need to further explore, but that's where we are. Okay, yes?
So using micro moments is one way to sort of handle the mechanical addition that Legit brings to the welfare analysis. What do you think about the Aviv-Nevo sort of adjustment?
Okay, so let me just go to the first part of your question. So the micro moments, what they help us do, right, is let me just go back to the equivalent of here. What they do is they actually let us, get the predicted much more closer to the observed, right? So the idea, in an ideal world, what we'd really want to do is we want to have a model that's good enough that we can actually, we can do both things right? So we can actually use our model to say, hey, we got exactly the observed chairs, right? So that's where they help us. Right, and in ideal, actually, maybe you say, if I even get the observed, what I should try to do is I should try to see, can my model match it, and if it does, then that's the model I should use for welfare, right? So that's just for your first part. In terms of the Akerberg-Reisman, so my view of the Akerberg-Reisman is you can think of it as doing something similar to what I advocated here. It's to basically say, okay, let's let the Xi change, but now we're going to let it sort of change, use historical data to tell us how it should change. I think there's two main problems with it. One is the fact that, it's not really, they do offer a model in the paper, okay, but it's not a great model. It's not clear how it applies in many situations. So if you want you want whatever solution you have to be kind of based in a model and in sound theory, I don't know that, you could say that what they offer, passes that bar. That's one. The other is more of an empirical point, which is, suppose we actually did that here. Right? So take the red bus, blue bus problem. So suppose what I had is historically, I saw a bunch of these introductions, right? So I saw a red bus, a blue bus introduced, and then a purple bus, and then a green bus, and all kinds of different colors. And I used that to kind of calibrate their approach. Actually, I should say, sorry, I kind of stepped straight into it. Maybe let's bring everyone up to date of what Akerberg-Reisman do before I talk about them. What they propose to do in a simple thing is to basically, let me go all the way back here. Sorry, I should have done this. What they propose to do is say, I just need a function. So take that utility. What they say is, let's add a term there. Let's say, call it a function f of the number of alternatives that are offered. right? So it's f of jt, right? Where f, just think of it in the simplest form, just think of, you know, a parameter times jt, okay? Where jt are the number of product they're offered. And as I introduce more and more products, I'm going to change the utility, right? And the idea is I'm going to change basically the xi, the same way that, you know, I was saying there, right? So my points were A, where is this coming from? And B, suppose I use historical data to estimate this. So suppose I did this with all these introduction of buses. You say, oh, well, you know, every time I introduce a new bus, there's the utility, you know, I'm going to change the utility accordingly. And I'm going to find, you know, if I get the right functional form, maybe I'll figure out how to change things, okay? But suppose I do that, and then one day someone proposes, introduces, you know, a subway station, okay? At that point, well, we know whatever we have historical data, we might as well throw it out the, out the window, because that's not going to inform us about the introduction of a subway station, right? So we're back to the same old problem now that you have to sort of say, well, what do I want to take, right? And if you actually really do believe that the historical events were the relevant ones, then maybe what you should do is try to use those historical events, right? Just like we were talking, to actually estimate your model and get a good model of the predictions, okay? So that's maybe a better way of using kind of the historical events rather than trying to have this kind of ad hoc correction, okay?